All right, so this is the presentation for 7.4c. I know the title says geometric sequences, but we'll actually be talking about what are called geometric series. The PowerPoint for this can be found on Canvas, so if I move through any parts too quickly, you can either pause the video or find the PowerPoint presentation on Canvas. But to begin, what a geometric series is the sum of the terms in a sequence. We learned that a sequence is just a list of numbers that has a pattern to it. So a series is when we take the pattern and we add up however many terms we're told to add together. At that point, once we're adding them together, it is considered a series instead of a sequence. Now, for a series, there are two equations that will work to calculate more quickly the sum of the series. Sn, which represents the sum of the first n terms, can be found using either of these equations. The way that you'll know which equation to use is depending on what you're given or what your ingredients are. If you know the first term, the common ratio, and the number of terms, the top equation is going to be the easiest to use. If you know the first term, the common ratio, and the last term, or another term in the sequence really, then the bottom equation will be easier to use. That being said, most of what we're going to use today is the top equation. So let's take a look at example 7. In this scenario, Kateri wants to set up some dominoes so she can knock over one, which knocks over two more. Each of those knocks over two more, so on and so on. If she wants to make 6 rows of dominoes, how many will she need in total? So, in the first row, she should have 1 domino. What that means is that our first term is 1. She wants 6 rows. That tells us how many terms we'll have. So n will be 6. Finally, each 1 domino knocks over 2 more, or twice as many. So the number of dominoes needed doubles in each row, meaning our common ratio is 2. That's what it means to be twice as many, to multiply by 2. So now that I know my first term, my number of terms, and my common ratio, I can plug them into the formula. By simplifying, 2 to the 6th power is 64. You can use a calculator for that, or you can brute force calculate that on paper. But 2 to the 6th is 64. 1 minus 64 will be negative 63. And negative 63 times the 1 up front still leaves us with negative 63. So we simplified the numerator, and it became negative 63. In the denominator, we have 1 minus 2, which is negative 1. Negative 63 divided by negative 1. A negative divided by a negative is a positive, and 63 divided by 1 is 63. So 63 is equal to the sum of our first n terms. In this case, the sum of our first 6 terms. So that being said, Kateri will need 63 dominoes to set up 6 rows to knock down the way that she plans on knocking down dominoes. In the U-Try, these are the answers. Again, this is on Canvas, so you can look at the answers more slowly. If you have questions, make sure that you ask when we get back on Monday. Example 8. This example is actually going to be a little bit tricky and more time-consuming than I'd like, so we're actually going to move past this example. You can go through it on your own, and if you can get it, good. And if not, that's okay. We are going to use the U-Try as your actual example 8. So find A1. Our job is to find A1 in a geometric series for which Sn, or the sum of the first n terms, is 5,465, n is 7, and r is 3. If we need to round to the nearest tenth, which is 1 decimal place. So I've been given some information. Sn is 5,465, n is 7, and r is 3. So in for Sn, R, and N, I'm going to plug in these numbers. From here, it's really, again, just a simplifying problem. 3 to the 7th power can be calculated in a calculator, and that should give you 2,187. From there, we can subtract. 1 minus 2,187 is negative 2,186. In the denominator, 1 minus 3 is where we get negative 2 in the bottom. From here, 5,465 is equal to A1 times negative 2,186 divided by negative 2. A negative divided by a negative is a positive, and in your calculator, you can type in 2,186 divided by 2 to find 1,093. Now, 1,093 is multiplying to A1, so my last step to find A1, or to get A1 alone, is to get rid of this 1,093 by dividing both sides by 1,093. On the right side, the 1,093s will cancel out, leaving us with A1, and on the left side, 5,465 divided by 1,093, again, just a calculator problem, leaves you with 5. So we figure out that our first term is 5.